All right, hey everyone. In this video, we're going to go through the Enrollo chapter check number 4, the tech active one, and we're looking at question number 2. So I did start this and then thought, where is F? Like it's started to define F but didn't continue. So I am just going to write it down. Now, I got it from the solutions. I don't know whether it was on anything else, but I've taken these questions from the printable version. So if you're wondering where F is, this is it. Very hard to write when your screen's up. Okay, and there's g of x. So we've got two functions. So question 2a, express x to the power of 4 minus 8x in the form blah, blah, blah. So you can see it's been factorized. So I'm going to, and it's quite a long one to do by hand. So let's just see how far we can get on the calculator. I might just clear everything. When I did this before, it closed my calculator down. Oops, what am I doing? I didn't mean to do that. All right, so we want to factorize, and I'm going to find which menu it is. All right, so we want to factorize the x to the power of 4 minus 8x. All right, so there it is there, and it kind of looks the same as this, but not entirely. So we've definitely got the x out the front and the x minus 2, but you can see we've got this quadratic here and they've put it into turning point form. So we do need to just change that. So let me just quickly write this down, x minus 2, and come back up, x squared. Oh, that's not a hard one to do by hand. All right, so we just need to put that into turning point form. So first part stays the same, and then this is going to become x plus 2. Hold on. No, it's not 2. Sorry, guys. Let me just do the full method. I was trying to do it without. All right, so x squared plus 2x plus 2 on 2 squared minus 2 on 2 squared plus 4. All right, so then we've got x plus 1. And then we've got minus 1 plus 4, so it's going to be plus 3. All right, so not a difficult one to do, as long as you write the number in. Okay, so question 2b, describe the translation that maps the graph of y equals f of x onto the graph of g of x. So we've got f of x here, and we've got g of x. So I'm just going to sketch them both, and I'm going to do it in the calculator. Usually I would do it on Desmos, but you know, we do have to get used to doing things on the calculator, because we're not going to have Desmos. Am I all the way down there? Okay. We're not going to have Desmos in our exams, are we? Or USAC, so. All right, so we've got, and I'm wondering whether I should define this. I probably won't. X to the power of 4 minus 8x. And then we've got x minus 3, x minus 1, then x squared plus 3. Tick that. All right, let's see what they look like. So where we want to go from f of x, so my f of x is the red. Is that right? Let me just think. To the g of x, which is blue. All right, so we're going from red to blue. So I can see that it's only been translated. All right, they both have the same shape. It's just been shifted. So what I can do on my calculator is I can just go to, I never find, okay, so min, function min, and it's asking me, it's flashing, it's like, hey, which graph would you like? I might just start with the red one. Go. Oh, Okay, well, let's choose that one then. It's not going to let me choose the other one. And it's not in exact form, which is a little bit annoying. So let's see what the... No, it's not letting me go over. Alright, let's see if we can do the other one. You're going to give me the other one? Oh yeah, there we go. Alright, so 2.2, okay, so it's a little bit annoying. Let's do these on the other screen. So just so, because on your graphing screen, we're not going to have exact values. So I'm just going to copy, go into main, and we can just do function. We can figure out which one it is. Function min. Again, it's giving me a decimal, so I just need to change it from decimal. All right, so there it is. And then let's do the other one. So, oops, wrong one. Let me just highlight you. Should have done this one first, actually. Doesn't matter. Main. Now, why is it giving me that? It's a bit annoying. So, it gave it to me in exact form earlier, but not for that one. Okay. Alright, so my y value should be the same, and my x value, wonder why it's done it like that. That's really annoying. Alright, I was just playing around with it. I have just put it back to decimal, so you can see your y values are the same. And our x values, there's just a difference of 1. So it's quite easy to see. It's not, it's an integer value, which is quite easy to see. So I would have preferred exact values, and there was a way I was going to do that if we needed to. But you can see I've just put it back to decimal, and we can see it's just been shifted to the left 1 unit. All right, so can I write that down? Where did I put my stylus? All right, so it's left 1 unit. So I'm just going to go back to the calculator just to show you the graph of each of them. All right, so remember the red is our f of x. The blue is our g of x. We're mapping the graph of f of x onto g of x, so it's gone across 1. So left 1 unit, or 1 unit in the negative direction of the x-axis. All right, part 2ci. Find the values of d such that the graph of y equals x plus d, f of x plus d has one positive x-intercept. So what we've got happening here is we've got a vertical translation, not vertical, horizontal translation. So I'm going to go ahead on my calculator. Let's go back to our main screen, and I'm going to use define. I should have used define from the start. You can keep cutting and pasting, but all right, so that's my f of x. So if I'm wanting to now graph that, I can just put in a slider. So f of x plus d. So I can graph them, and this one here will add a slider. Whoops. Sorry, I should have ticked it. Added the slider there. So you can see at the moment d is equal to 1 because that red one shifted across 1. So we want one, what did we want? One positive x-intercept. So at the moment, if we're looking at the graph of it, if I just zoom in to this part here, it is crossing the origin. So basically, let's just put our slider back on. If I was to go to 0, Okay, let's just change it. So we couldn't see it because it was too big. Let's go up by 0.1. So we might be able to actually see it move across now. All right, so when I am decreasing D, so see how it's moving closer. So there it is at 0, the original one. So when D is getting smaller, it's going in the other direction. So we want D to be less than or equal to, just less than 1. So when it's equal to 1, it's on the origin. When it's greater than, it's past it. So anything greater than 1 is going to give us just one positive x-intercept. So D has to be greater than 1. All right, so if we just look again, let's put it back where it was originally at 0. All right, and we're increasing D. So there's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then 1. And then as soon as I go bigger than 1, all right, we've only got one x-intercept. Sorry, we've only got one positive x-intercept. The other one is negative. So if I was to zoom out again, it might be easier for you to see the shape of the graph. All right, so you can see it there. All right, so still having positive x-intercept, but the other one is a negative. All right, and then part 2, find the values of D such that the graph of y equals f of x plus 2. D has 2 positive x-intercepts. Oh, okay, so that just means D is less than 1. All right, so we can't have it equal 1 because 0 is neither positive or negative. So yeah, it's just the opposite, and I pretty much just showed that. Okay, bye. All right, I just checked the answers and didn't realize with 2C part 1 with my slider, if I kept going, clearly that graph would go and then we would have both x-intercepts are negative. All right, so that's my bad not recognizing that. So basically it's going to hit that origin again at 3. So D has to be greater than 1 or less than 3. So let's just change that. So D has to be greater than 1 or less than 3. All right, and the second one is correct. All right, bye girls.